Hi students, welcome to Year 9 Science and Unit 2, Our Amazing Earth. This is video number 3, and in this video we're going to introduce the idea of plate tectonics. So the idea is that you're just able to describe the theory of plate tectonics. Why is plate tectonics important? Well, we've introduced the idea already about continental drift. Wegener's idea that the continents used to be glued together, stuck together in some way in a jigsaw fit, that after some time started to drift apart. And so now the position or the geography that we see around the Earth is basically not representative of what it has always been. So Wegener had a really good idea, continental drift, but he didn't have a mechanism. He couldn't explain how the continents went from one place to another. We're going to be actually having a look in another one of these videos at Hess's observation. He introduced the idea of seafloor spreading. Now, seafloor spreading is an idea that actually fits very nicely with the idea of continental drift. That is, seafloors moving apart or growing over time. It did support Wegener's idea, but it still didn't explain everything, and it's something that we'll have a look at in a little bit more detail later on once we understand this whole idea of plate tectonics, because the theory of plate tectonics was the unifying theory that actually explained continental drift, Wegener's idea, Hess's idea about seafloor spreading, and also the global distribution of volcanoes and earthquake zones. These either link together as explanations, or they provide lots of evidence that suggests that these ideas are really good ideas. And don't forget, when we're talking about a theory, what we're talking about is an explanation for a phenomenon. So the observations that we make are the continents have a jigsaw fit. The continents have similar rocks and fossils, which suggests that at some point in the past they were more closely joined to one another, and land animals had the opportunity to move from one continent to another, but we couldn't explain why. Plate tectonics is the theory that allows us to explain why continental drift happens, and also why seafloor spreading happens, but we'll give you a separate video on that one. So what is plate tectonics theory? Why is this such a good theory, and why does it explain things like continental drift? Well, put simply, plate tectonics is the theory that the Earth's outer shell, the solid part of the Earth, which includes the crust and also the upper part of the mantle, and we'll have a look at just a quick cross-section of these just in case you've forgotten what these terms refer to, is a region of the Earth known as the lithosphere. And it's basically solid rock. That solid rock is the what we base this whole idea of plate tectonics on. So the lithosphere itself, the solid rock, the crust and the upper mantle, all being part of this surface of the Earth, is broken up into a number of large and then slightly smaller blocks or plates. Each of these plates can actually move as a single entity, and the important thing about them moving as a single entity is they don't all move in the same direction or at the same speed. And realistically, this is critical to our explanation of things like continental drift, because we can explain how South America and Africa might have moved apart from one another, but if they're all moving equally apart at the same rate, how did India get from being part of that southern group, the Gondwanan group, right up into the hitting Europe and Asia? How did it get that far? So there's an interesting part of plate tectonics that tells us that even though we do assume that the lithosphere is split up into all of these different plates and all these plates can move, the plates themselves are not all moving in the same direction at the same speed. Having said that, if you're on the plate is relatively stable. And this is an interesting thing that we're going to look at for Australia, because Australia sits in the centre of one of these huge plates. And Australia, tectonically speaking, is not that unstable. We have had earthquakes. We have evidence of volcanic activity in the past, but neither of those are current, or they certainly don't occur very often in the present. And our distribution of or our incidence of volcanoes and earthquakes is very, very low compared to other areas in the world. So that's why we describe Australia as a fairly stable in terms of its tectonics. Other countries, of course, are much more unstable. Earthquakes are a part of life, something that builders have to plan for, and likewise volcanic eruptions still occur today in certain places around the world. And of course, communities that are anywhere near those need to be aware of what to do and what signs to look out for in case the volcano is going to erupt. So hopefully we can use this idea of plate tectonics to help us to explain not just continental drift, not just seafloor spreading, but also the distribution and incidence of earthquakes and volcanoes. Just to be really clear about what it is that we're looking at. So if we're going to look at plate tectonics, we're going to have to try and think about the mechanics of this whole process. What we're doing is moving great slabs of rock. And how does that happen? Well, the lithosphere itself, as we mentioned, consists primarily of the crust and the upper mantle. It's not very thick. There is a difference between continental crust and oceanic crust. You get a little bit of a sense of that with this diagram. Oceanic crust is much thinner, continental crust much thicker. And as a consequence of that, we see that the crust itself isn't a consistent thickness all the way around. It's not like crust on a loaf of bread. There's thick sections and there's thin sections. And underneath that is a layer of upper mantle that is also pretty rigid. And together with the crust forms this part of the Earth that we call the lithosphere. Underneath that is a layer which is called the asthenosphere, and the best description for it really is it's plastic. It is fluid, so therefore it's capable of flow. And so our idea is that the solid rigid stuff is actually capable of moving across the liquidy stuff or the fluidy stuff underneath. Now this is thinking of a liquid more like honey or syrup, something that's very viscous, something that's very thick, not something that's like water, for example, that's much thinner, that flows more easily. So it's very thick, and it allows these to move. That's the idea, is that we've got this section of crust and upper mantle that's basically been smashed up into these different blocks, and the blocks can move relative to one another, apart, together, or side to side. And each of those we're going to have to look at in a little bit more detail further on. But hopefully we just get a little bit of a sense in our mind at the moment of this upper part of the Earth. There's a whole lot of stuff going on further into the mantle and the outer and inner core that are not relevant to us at this stage. We're just concentrating on those lithospheric plates, the plates that are part of this theory of plate tectonics. And we'll have a look at that in a little bit more detail in the next video. Thanks for watching.